Welcome back everybody. This is our 15th class in JEE mains previous year questions for chapter moving charges and magnetism for class 12th. Before this video we have made 14 videos in this series and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So if some of your friends are preparing for those, then you can guide them through. Also, if you find these videos useful, then do press the like button, share them and subscribe to our channel. And if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Even a small amount of help will be highly appreciated. So with this, let's start today's video. And in the previous one, we completed around up to 100. So today we will go further. That was 100. 99, that was 100, and there was in 101 we have problem in statement. 102 we solved, and today we will start with 103. So as per statement, a moving coil galvanometer has a coil with 175 tons and area is mentioned to us. So let's slide it down, and start. So N is 175, area is 1 into 10 raised to power minus 4 meter square. It uses torsion band of torsion constant 10 raised to power minus 6 Newton meter per radian. Here it is constant, and which constant it is? When we write that C is equal to, or torque is equal to C times theta. This is the constant which is mentioned here. Here theta, as per this value of constant, should be in radian. So value of C is 10 raised to power minus 6 Newton meter radian. The coil is placed in magnetic field B parallel to its plane. The coil deflects by the 1 degree for a current of 1 milliampere. The value of B approximately is equal to. So it is mentioned that coil deflects by 1 degree for the current of 1 milliampere, means current sensitivity which is equal to deflection or current required to produce unit deflection. We say current required to produce unit deflection, and it is 1 milliampere by deflection, as here mentioned that 1 milliampere is for 1 degree and our torsional constant is given in the per radian. So we have to either convert this radian into degree or we will convert this degree to radian. So by default, when you do a physics question, you go by radian because degree is not in the SI units, or we can standard unit is degree, not radian and not the degree. So we will convert this 1 degree into radian, and we know that 180 degree is equal to pi radian and 1 degree is equal to pi by 180. So it will be divided by pi, and we will 180 here. So it will be 180 by pi into 10 raised to power minus 3 ampere per radian. So that's the current sensitivity here. Now we know in case of a galvanometer, torque required for rotation is equal to Ni, where N is the number of turns in the coil, I is the current, A is the area, and B is the magnetic field, into sine theta. Or we can simply write it like that: torque. In case of galvanometer, we simply have a coil with N number of turns. So for a coil with n number of turns, torque is given by m cross b, where m is the magnetic dipole moment. So m will be number of turns into I into area, that is formula for magnetic dipole moment, into B magnetic field, and as they have cross product, so we will have sine theta here. Now regarding theta, the coil is placed parallel to the magnetic field. So if this is the direction of the magnetic field, then coil is also in this plane. So the magnetic dipole moment vector, which is perpendicular to the area of the coil or perpendicular to the plane of the coil, it will make 90-degree angle with the direction of the magnetic field. This angle will be 90 degrees. So here we will get sine 90, and so sine 90 is 1. And torque is, we all know, that is c theta, torsion constant into theta, is equal to NIA P. And from this we can write that B is equal to c theta by NI into A. Now using all the values, value of C is already mentioned, that is 10 raised to power minus 6. Now theta here is 1 degree, and that 1 degree needs to be converted into radian, so pi into 1 by 80. Number of turns we have 175. Current is 1 milliampere. And moving ahead, we have area, that is 10 raised to power minus 4. So that will be 10 raised to power minus 7, and on top we have 10 raised to power minus 6. So it will be 10 pi divided by 175 by into 180. So further we can solve it like this, that it will be pi 175 by 80. And it is 18. Now after solving this, what we will get? We will get 0.000 into 9999, and it can be written as 0.00 and 1, and it can be written as 1 into 10 raised to power minus 3. So that is option C here. Option C will be the right answer. Moving to the next one. Resistance of a galvanometer is 50 ohm, and the maximum current which can be passed through it is 0.02 ampere. Resistance must be connected in order to convert it to an ammeter. So we have to convert it into an ammeter, and resistance is already mentioned and current is already mentioned. So to make a ammeter out of a galvanometer, what we do? We connect a shunt resistance in parallel to it. So let's draw the diagram, that this is our galvanometer, and we connect a shunt resistance here. So now it as a whole it works as an ammeter. Its resistance is mentioned, and maximum current that can pass through it is 2 into 10 raised to power minus 3 ampere. Now as per mention, that we have to make it work like a ammeter with range 0 to 0.5 ampere. So if our original current is 0.5 ampere, it means out of these 0.5 amperes, the current flowing through this resistance, that is RS shunt, will be equal to 0.5 minus twice into 0.3 ampere, because this is the maximum value which can go through galvanometer without damaging it. So all the remaining current should pass through RS, and it will be approximately equal to 0.5, as this value is very small. So we can say current flowing through this RS is almost equal to 0.5. This is for our so that we can make calculation easier. That's why we approximated it. You can take exact value. Now as we can say, if we take 2 points here, point A and point B, we have two resistances. One one resistance from the galvanometer and one resistance from the shunt resistance. Both are connected in parallel. So potential across those two resistances should be equal, or we can say V potential across point A and B should be equal if we write with the help of galvanometer, or if we use with the help of shunt resistance, or we can say current going through galvanometer into resistance of galvanometer, that is the potential drop across galvanometer, should be equal to potential drop across this RS. So it means current going through this shunt resistance into its value. Now value of Ig is 2 into 10 raised to power minus 3, and resistance of galvanometer is 50 ohm. Current in the shunt resistance is almost, that is 0.5, so 5 into 10 raised to power minus 1 and into Rs. So leaving this, we will get 50 into 200 into 10 raised to power 3, so 10 raised to power minus 1 we will have from this, and from here we will have and divide 5 into 10 raised to power minus 1 is equal to Rs. These will get cancelled and Rs will be 0.2 ohm. That is option D. So option D will be the right answer. Moving to the next one. The galvanometer deflection when key K1 is closed but K2 is open. So K2 is open and K2 is closed. Sorry, it is mentioned that K2 is open and K1 is closed. So this is closed. Equals theta naught. On closing K2 and adjusting R2 to 5 ohm, deflection in the galvanometer becomes theta naught by 5. The resistance of the galvanometer is then given by neglect internal resistance of the battery. So we have to neglect the internal resistance of the battery. Now let's plot the diagram for both of the cases, that when K1 is closed and K2 is open. When K2 is open, this resistance does not play any part here. So our effective circuit looks like this. So case 1, K1 close, K2 open, and effective circuit looks like this. We have a R2 of 220 ohm, R1 of 220 ohm. We have a battery here, and this is closed. This upper circuit will not, upper part will have no say in the circuit, and it looks like this. There should be no, there should not be this middle wire. I think this middle wire is wrongly drawn or due to some error. The circuit should look like this. Original circuit should be like this. So now using this one, if K2 is open, then upper part will not will be in the circuit, and we will have direct galvanometer here, and this will be our circuit. Now here, this galvanometer has a resistance in series. Suppose its resistance of the galvanometer is Rg. So now this galvanometer is working as a potentiometer or as a voltmeter. So potential drop across it, then that way I can easily find out that suppose there is current I flowing in this circuit. If circuit's current is I and batteries, that battery is suppose E, then the current will be I is equal to E by 220 plus resistance of the galvanometer. So this is the current in the circuit, and this is again, as this is the current in the circuit, same current will flow through the galvanometer as this resistance and the galvanometer in the series. So we can say this value of I is proportional to theta naught, as mentioned, that when we have this condition, the deflection is equal to theta naught. So we can say this value of current is proportional to theta node. And why we write this proportionality? Because from the formula of the torque, we know that torque in case of galvanometer is equal to NIAB, and sine 90 we are assuming here, and torque is equal to C theta, NIAB. Now keeping all other variables constant, C constant, C is the torsional constant of the coil, N is the number of we can say loops, I is the current, A is the area, and B is the magnetic field. So from this we can say theta or deflection is proportional to the current, and that's why we are using this methodology here, that we first found out the current, and that current should be proportional to the amount of deflection in the galvanometer. Now moving to second part, case 2, that it is mentioned now R2 value is 5 ohm and K2 is also closed. So now circuit is something like this. So we have a 220 ohm resistance here. K2 is closed. So this R2 is also playing part in the circuit, and its value is 5 ohm. And here we have galvanometer. And this is our battery. So now this is the circuit. Now, okay, one thing more. Let's assume that was I1. This was I1 current. And here we were assuming that current is I2. So what we will do, we will find out the current in the second scenario. So now I2 will be potential of the circuit divided by the total resistance, and to find the total resistance, we know this 5 ohm and this galvanometer are in parallel. So suppose as already mentioned, that resistance of the galvanometer is equal to Rg. So resistance is equal to Rg. It means Rg and 5 ohm are in parallel. So first we have to find out their parallel resistance. So parallel combination of Rg and 5 will give us 1 by 5 plus 1 by Rg. So that will be 5 Rg or Rg plus 5, or effectively 5 Rg by 5 plus Rg. This is the combined resistance of both these, and total resistance of the circuit will be 220 plus 5 Rg divided by 5 plus Rg, taking LCM. We can find the total resistance after taking LCM, and it will be 5 plus Rg, 220 into 5, that will be 1000 plus 100, that 1100, plus 220 Rg plus 5 Rg, so 225 Rg. This will be the total resistance of this circuit. And now value of the current I2 will be potential, that is we have assumed to be E, divided by this value. So it will be 1100 plus 225 Rg divided by 5 plus Rg. So this is the current of I2 which is flowing in this circuit. But we have been given deflection in the galvanometer, and deflection in the galvanometer depends upon the amount of current flowing through galvanometer. And as I2 starts from battery, after moving through 220 ohm circuit or 220 ohm resistance, I2 splits here in the two parts. Some of the part or some of the value of current goes through 5 ohm and some of go through galvanometer, that is Ig, and we have to find out this value, because deflection of galvanometer is proportional to current flowing through it, and value of current flowing through a galvanometer is Ig. So we have to find out value of Ig in terms of I2, and that we can find using parallel relation, that when we have two resistances in parallel, then the value of current flowing through any of these one. Suppose we have to find out current value of Ig. So Ig will be, as we are finding a value across this resistance Rg, so we have to take opposite resistance 5 divided by total resistance, that will be R, that sorry, not R, 5 plus Rg, that is total resistance of the system 5 and Rg, multiplied by the original current, that is I2, and this is I2. So E 5 plus Rg divided by 1100 and 225 Rg. So 5 Rg get cancelled, and here we can divide this whole equation by 5. So we will be left with E by 220 plus 25 Rg. That's the value of current flowing through the galvanometer in the second case. And as mentioned, this value should be proportional to theta by 5, because here deflection is theta by 5. So this value is proportional to theta node by 5. And let's copy this so that we can compare both. Here we have this value that is proportional to theta node, and we just solved another value that is proportional to theta node by 5. So we also write that E by 220 plus Rg is proportional to theta node. Now let's divide both of these equations and let's see what we have. Dividing these both, we get E 220 plus 25 Rg divided by E 220 plus Rg is equal to theta node by 5 and divide by theta node. So theta node cancelled, E cancelled, we have 220 plus Rg, 220 plus 25 Rg is equal to 1 by 5. Taking cross product, 1100 plus 5 Rg is equal to 220 plus 25 Rg. Subtracting, we will have 900 minus 20, 880 is equal to 20 Rg, and from this Rg will be 44 ohm. It is the resistance of, so let's check, do we have, so we don't have 44 ohm here, so I think we made a mistake, and mistake is, yes, mistake is here, that when we divided 1100 by 5, then it became 220, but 225 by 5 should be 45, it should be 45, so that was the mistake. So we need to correct it. So it will be 45, it will be 45, it will be 45, here we will have 45, here we will have 40, and from that it will be 22 ohm. And now our answer matches. Now we have 22 as an option, so 22 ohm will be the right answer here. Moving to the next part, next question, sorry. A galvanometer whose resistance is 50 ohm has 50 divisions in it. So Rg is given to us and number of divisions are given to us. Rg is 50 ohm and divisions are, we have 25. It is mentioned that when a current of this value passes through its needle, the needle deflects by 1 division. So we have been given current sensitivity, and we know that we can find out galvanometer current by multiplying current sensitivity to number of divisions. Current sensitivity is 4 into 10 raised to power minus 4 into 25, so it will be 100 into 10 raised to power minus 4 or 10 raised to power minus 2 ampere is the value of current, galvanometric current that can maximum have a galvanometer have. To use the galvanometer as a voltmeter for range 0 to 2.5, it should be connected a resistance. So to use it as a voltmeter, we need to attach a resistance in series, and our circuit should look like this. We need attach a resistance R in series with galvanometer here, and that current in this circuit that should be equal to Ig or lesser, and value of Ig is 10 raised to power minus 2 ampere, and value of this galvanometer resistance is also 50 ohm. So we need to convert it into voltmeter of 2.5. So if this is point A, this is point B, then VAB is given as 2.5 volts. So using this, we can find out the current. Current in this circuit, that is Ig, should be equal to VAB divided by total resistance, that is R plus galvanometric resistance, means R plus 50 ohms. Value of Ig is 10 raised to power minus 2, and we have 2.5 here VAB, and this is R plus 50 ohms. Crossing these, we will get R plus 50 is equal to 2.5 by 10 raised to power 2, or 2.5 into 10 raised to power 2, that will be 250. So R comes out to be 200 ohms here. So option B will be the right answer here. Moving to the next one. Galvanometer having resistance of 20 ohm and 30 divisions on both sides has figure of merit. So it has 30 divisions on the both sides, means it is a type of galvanometer whose equilibrium point is at center, and it can deflect on the both sides, means on the one side it will show positive current, and on the negative side it will show negative current. And in this case, we students often make a mistake that they count these number of division as doubled, that we have 30 divisions here and we have 30 divisions here. So this galvanometer has total 60 divisions, and a maximum current of this galvanometer, or Ig, is equal to 60 times the current sensitivity. That's not the right process, because maximum this galvanometer can deflect from this point, from its equilibrium position to this position. So as a whole, it will only deflect by 30 divisions, and similarly for the negative current, it can deflect up to this much, so 30 divisions again. So its current or galvanometric current Ig will be number of division, that is 30, multiply its figure of merit, that is also known as current sensitivity, 0.005. So 5 into 10 raised to power minus 3, that be 150 into 10 raised to power minus 3, or 15 into 10 raised to power minus 2. This is the value of galvanometric current. Resistance that should be connected in series such that it can be used as a voltmeter up to 15 volts. So again, this is similar type as we solved previously. We have a resistance R here, we have a galvanometer, the current flowing through, maximum current that can flow is 15 into 10 raised to power minus 2. So I is equal to V by R plus Rg. Value of I is 15 into 10 raised to power minus 2 is equal to potential, that is 15 volt, divided by R. R we have to find out, plus resistance of the galvanometer is 20 ohms. So crossing, we will get R plus 20 is equal to 15 by 15 into 10 raised to power minus 2, that will be 100. So R is equal to 80 ohm, that is option C. So with this, we end this video here. Hopefully what we have covered here till now is helpful to you. Again, if you find these videos useful, helpful, then do press the like button and share these videos as much as possible. Subscribe to our channel, and also if you want to support us financially, then you can scan any of these QR codes on your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.